Welcome back with next chapter 14, electric current and its effect. Electric circuit. As you have already learned in classics that electricity is one of the most useful form of energy. So before moving that electric circuit, we want to know that what is electric current. Electric current is a flow of electric charge through the defined circuit, and the electric current was discovered by the scientist Benjamin Franklin while he was doing research on electricity. Franklin knew electricity has two elements where one is positive and other is negative, and it flows between these two elements. During his research work, Franklin on a stormy day flew a kite up in the air with an iron piece tied on it. Suddenly there is a lightning and Franklin felt a big shock as the electricity charge flowed through the kite up to his hand. It was dangerous experiment but proved to be a very important for knowing the fact that electricity has a charge and it can flow or it has a current. Later on that Thomas Edison produced an electric bulb in his laboratory with the help of the flow of electric. Then based on that Edison research, rural electrical administration was formed which was helpful in bringing electricity to that rural area. Today, due to that effort of great scientists, we all are able to use electricity for various purposes. Without electricity, there is no life. So now we move to that electric circuit. Electric circuit flow in an electric means there is a circuit formed of battery, electric sources, conductive media, and load of resistance. We can say that an electric circuit is a path for flow of electrons with electric charge from a voltage or a current source. The point where those electrons enter on that electric circuit is called the source of electrons or electric charge. The point where the electrons leave an electrical circuit is called the returns of the earth ground. So electric circuit is the path in which that electric current flow from a source across various components, and electric circuit diagram is the diagrammatic representation of an electric circuit. Electric components. The various parts, elements that are used to make an electric circuit are called electric components. For example, cell, battery, connecting wire, bulb, switches, etc. Battery is the combination of two or more cells, and the components connected in series are connected along a single path, and the rate at which current flow from one device to another is same. Electrons flow from this single path. The components connected in the parallel are connected directly to the power source to the same voltage is applied to each component. Electric symbols. As it is circumstance to show the electric components in a circuit diagram, they are denoted or represented by a specific symbols, and these are known as electric symbols. Heating effects of electric current. As we have learned earlier that the energies can be transformed. Electric energy is transferred or converted in heat because of the resistance of the component during its flow in the closed circuit. This heating effect is used in large number of electric appliances and used in home and in the industry such as the room heater, water geyser, electric kettles, etc. Immersion rod used for heating the water for bath is the live example for heating effect. You may notice when the rod is not connected to electric supply, it is not hot. When you connect it to that electric supply after a few seconds, you may feel that it is very hot. Heating effect. All appliances which produce on passing electricity are based on the principle that heat is produced when electricity is passed through a wire. The wire or the coil of wire is known as element or that heating element. The amount of heat produced in a wire depends on the length, thickness and the material of the wire. Common material used for heating elements are tungsten and nichrome. And nichrome is a material made up of nickel, iron and chromium. The filament of an incandescent bulb is made up of tungsten. For this reason, connecting wires which are made up of materials like copper are not hot to touch. Efficiency of electrical appliances. When electric energy is partially converted into heat energy, it leads to the wastage of energy in machines and appliances where the heat is not utilized. Stars on electrical appliance indicates the efficiency or rating of the appliances. More the number of stars, less is the wastage of electrical energy. Household safety devices. There are two types of household devices. One is the fuse and the second one MCB, miniature circuit breaker. First one, fuse. As we have learned above that the switch is an important or essential component in a circuit which control the operation of circuit. Every circuit is designed for a certain load of each appliance. During flow of electrical energy in any circuit, some energy is converted into heat. To avoid this overheating of an electrical appliances, one safety device is arranged in every electric circuit which is known as fuse. Fuse is generally made up of a metal or a alloy of zinc, copper, aluminum, etc., having that has a very low melting temperature. So it works as a principle of heating effects of electric circuit. Fuse is used for the prevention towards damage due to any sort of fault in that closed circuit. Today that we are using that miniature circuit breaker which is also used in a heavy machines in place or even in addition to the fuse being on a safe safe side. Then MCB also called that a safety device which is used in household fuses. MCBs to break the circuit or go off automatically overload in the circuit. Magnetic effect of electricity. That Oster discovered the magnetic effect of current. When a magnetic compass is brought near a current carrying conductor, the needle of the compass gets deflected because of the flow of electricity which produces magnetic field. This shows that the electric current produces a magnetic effect. A conducting wire behaves like a magnet when electricity is passed through it, and hence the needle in the magnetic compass gets deflected. Factors on which the magnet effect of that electric current depends. First is it is directly proportional to the number of the turns in the coil. Second, it is directly proportional to the amount of the current. Electromagnet. Electromagnets are used in electrical appliances such as electric doorbells, electric motor, which are used in fans, refrigerator, air condition, washing machine, etc. Simple use of electromagnet is very explained through that the working of an electric bulb. So electromagnet is a temporary magnet in which the current carrying wire behaves like a magnet. Uses of electromagnet. They are used in devices and appliances like motor, generator and loudspeaker, hard disk, MRI machines, etc. They are used in magnetic levitation by which an object is suspended with no support other than magnetic field. They are used for separating iron materials from the zinc. They are used in separation of iron from ore. They are used to magnetize and make permanent magnet. Electric bell. An electric bell is a device whose working is based on the magnetic effect of electric current, and it uses an electromagnet for this purpose. First we discuss about the construction. An electric bell consists of a curved iron rod mounted on a metallic strip, a switch, a hammer, a gong, and the source of electricity. The connecting wire is wound over the iron rod so that it behaves like an electromagnet when current passes through it. One end of the wire is connected to a contact screw through a switch and a source of electricity. The end of the wire is connected to the lower end of the hammer, which is called armature. This armature rests on the contact screw and a metallic gong is placed in front of the hammer. Working of electric bell. When the switch is pressed on, the current flows through the wire and the iron rod becomes an electromagnet. The electromagnet attracts the armature, and as the armature moves towards the gong, it strikes the gong to produce sound. Meanwhile, the connection between the armature and the contact screw breaks, resulting in a break in the circuit. Because of this, the iron rod ceases to be an electromagnet and the armature returns to the original position. This process is repeated till the time his switch is kept in on position.